All right, hi. This is hopefully the last section that you will all be learning by video. Hopefully I'll be back soon, but we're going to take notes over section 3.3, which is completing the square. You might have covered this in Algebra 1. I highly doubt it, but it does pop up on the EOC and sometimes on the ACT, and it is very useful in Algebra 2. So here we go. It's going to be a great time. The goal of this section is to be able to turn something from standard form into vertex form. I've been telling you guys for the past couple of weeks that there is a way to do it. You just don't know how yet. And so today we're going to learn how to take it from vertex form from standard form and turn it into vertex form. Okay. And so obviously you don't have algebra tiles, so you're going to watch me do this next section here. Okay. And so what this means, if you're following along in the notes, let me show you what's going on here. So I have these algebra tiles, okay? And it says, using the algebra tiles, complete a square for the following expression, which is x squared plus 6x. So these square little tiles here, those are x squareds, okay? Each side length represents x, okay? So we need one x squared tile because we have one x squared. And then these tiles right here, and it looks like I'm going to need a few more, but these right here, these are x tiles. Okay, the side lengths right here, these are the side lengths of x, and we're going to just assume that these side lengths are 1s. Okay, and we need 6 of them because it says 6x. So I've got 1, 2, 3, 4. Let me get a few more here. And 5, 6. Okay, so what we need to do is we need to make these, we're going to complete the square, and you're like, Bacham, I don't know what you're talking about, so just watch. We have 6 tiles, and if I break them up like so, and because obviously this is already a square, but you don't just have x squared, that's already a square. You need to add in now these 6 x's. Okay, so there's 1, 2, 3, and obviously if we kept extending this way, it would create a rectangle, so we don't want that. But since there's 6 of them, we could come down here and make it go that way. And then you're left with this little corner piece right here, which is what you have to fill in. We need to complete this square. And we need to know, so question 2 there asks, how many 1 tiles will you need to complete the square? Okay, well, let's see. Hopefully you might see it. There's 1, there's 2, there's 3, and 4, and 5, and 6, and 7, and 8, and 9. Okay, boom. So we need 9. So if we go back to our notes here, okay, and we're here, how many 1 tiles would you need? You're going to need 9 of them, okay? So what that means, what is the c value in the expression x squared plus 6x plus c so that it's a perfect square? It's 9. The c value would be 9. We created a perfect square. Okay? And so what we're going to do is now we're going to write the expression as a perfect square binomial. And so what that means is if we have x squared plus 6x, we decided that c was 9. This now factors, okay? Factoring, I told you was important. You have x plus 3 times x plus 3, which then comes down to be x plus 3 squared. That is a perfect square binomial, okay? And so that's the goal of today, is to be able to take things that are in standard form, find some c value, and then be able to write it as a squared binomial because we have a squared binomial in vertex form, okay? So that's the goal. So what we're going to do, and we'll do it together because obviously you don't have algebra tiles. I have algebra tiles in class if you want to use them when you get back, okay? So let's complete this table. All right, let's go back to here, okay? Now we have x squared plus 2x. So I'm going to take away some of those because now we only have 2 x's, right? Here's 1 and 2. And that means that I'm going to have to take away some of these squares as well. And that is a perfect square. You've made a square, you see? So the c value needed for this one is just 1, right? C equals 1. So that means that we now have x squared plus 2x plus 1, okay? And if we were to factor that, you would get x plus 1, x plus 1. So this is just x plus 1 squared, okay? All right, that one was easy. Let's do the next one, which is x squared plus 4x. So you've got x squared. So we need 4 tiles. So there's 1, 2, 3, 4. And hopefully you're able to tell then, to fill in the square, to make this a square, you're going to need 4 ones. Okay? Beautiful. So the C value that we need if it's x squared plus 4x is 4. C equals 4. Okay? So then that would be x squared plus 4x plus 4. Hopefully you can tell that that factors to x plus 2 times x plus 2. If not, you could go off to the side of your paper and do it. So then this turns out to be x plus 2 squared. Okay? We're going to start to see a pattern here. So let's keep going with these next two. We've got x squared plus 8x. Okay, so there's 4 x's. If we do 8, oh, I need some more now. Let's see. There's 4. Here's some 5, 6, 7, 8. Okay, now you've got 8 x's. So to fill in, well, let's see. There's 1, 2, 3, 4. Oh, geez. Then you've got 5, 6, 7. Maybe you already see the pattern. It's so great. 8. 9, 10, 11, 12, 13, 14, 15, and one more. As you can see, I dropped one, but one more would then be 16. Okay, so if you see the pattern, that's awesome. Some of us don't, though. So the C value is 16, so then you would have x squared plus 8x plus 16. That factors, hopefully you see that factors to x plus 4 and x plus 4. Okay, so then that factors to x plus 4 squared. Okay, let's do one more. Okay, the x squared plus 10x. So if I'm here, that's 8x, so we need 2 more x tiles. So that's here and that's here. So then we got to fill in that outside edge. Maybe you already see what's happening. You should see a pattern. Okay, so we do there, there. So we had 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, the C value that we need there is 25. So we go back here. C equals 25. So you've got x squared plus 10x plus 25. Hopefully you see that that factors to x plus 5, which then would give you x plus 5 squared. Okay, I hope that you see a pattern. Okay. So here in number 6, it says, look at the last column of the table. So that's this one right here, the last column. What are the patterns that you recognize? Okay. Specifically, how are B and D? So here's the B value. We're going to call this the D value. So here's B, here's D, here's B, here's D, here's B, here's D. Okay. How are B and D related? Well, hopefully you're seeing that this D value out here, these values, are equal to the B value right here divided by 2, right? Or sorry, yeah, 10 divided by 2 is 5. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1, right? Okay. What I'm also hoping that you see here, okay, is that the C value out here, okay, which is this, all of these, okay, that's the C value. The C value is just D squared, right? C equals D squared, right? Because it's 5 squared is 25, 4 squared is 16, 2 squared is 4, 1 squared is 1, right? I'm hoping that that's what we see. Okay. All right, so then if we use substitution, if we thought that, okay, well, D is B over 2, so if we plug that in there, then your C value can always be found by taking B over 2, because that's D, right? We determined that, squared. So if you ever need to find a C value, you don't know what a C value is, you're going to take B, divide it by 2, and then square it. Okay? Now for those of you who are like, Bacham, that's gypsy magic, just memorize it and move on with life. Okay? C is B over 2 squared. So this box basically just does exactly what I just did, okay? In order to find a C value, you're going to add B over 2 squared. Okay, nothing fancy about this little box here, but some of you like to look at concept boxes like that, so there you go. Okay, now let's do some vocab. And you might have to pause on this slide because I'm not going to spend too much time on it, but you can pause and write down the definitions. A binomial is a polynomial with 2 terms. Okay, so like x plus 2. That's a binomial. Just 2 terms. X squared plus 2x. Binomial. Okay, so a perfect squared trinomial. Okay, well, a trinomial, if a binomial is something with 2 terms, then a trinomial is x squared plus x plus 1. That's a trinomial, okay? So a perfect square trinomial is a trinomial that can be written as a product of a squared binomial. So basically, a perfect square trinomial, or if we go back, that's these, okay? That's a perfect square trinomial because you can write it as a squared binomial, okay? That's that definition. And the purpose of completing the square is to create a perfect square trinomial that can be written as a binomial squared and then solved using square roots. And you're like, Bacham, that's a lot of words. And I'm like, yes, it is. But once we start doing some problems here, I think that you're totally going to understand what's happening. Okay. So if you need to pause and finish writing down, now's when you do that. I'm moving on. Okay, here we go. Example 1. Find the value of C that makes x squared plus 14x plus c a perfect square trinomial, and then write the expression as a squared binomial. Okay, so we start with x squared plus 14x plus c. We know, because we just talked about it, that c is b over 2 squared. All right, so the b value is 14. We take 14, we divide it by 2, and we square it. 14 over 2 is 7. 7 squared is 49. Now you could have, if you wanted to, gone to your algebra tiles, got an x squared, got 14 x tiles, put 7 on the top, 7 on the bottom, and then filled in with the little bitty squares. You would have gotten 49. But my guess is you don't want to do that. That's a lot of work. Okay. So the c value is 49. So that means our new trinomial is x squared plus 14x plus 49. Okay? And then, so that's a new trinomial. Then write the expression as a squared binomial. Okay, well hopefully you see that this factors to x plus 7 times x plus 7, which you could write as x plus 7 squared. You should always be able to take a trinomial that is a perfect square trinomial and write it as a squared binomial. If it can't be factored and then written as a squared binomial, you've done something wrong. Okay? So, let's do a couple more like that. We're here, same thing. Okay, you start with x squared plus 8x plus c. There's your b value. So because c is b over 2 squared, that's 8 over 2, which is 4, and that's 16. So your c value is 16. So our trinomial is x squared plus 8x plus 16. That factors to x plus 4, x plus 4. This was one that we did in the beginning anyway. X plus 4 squared is your squared binomial. Okay? B has some negatives, but it's still done the same way, okay? Your B value is negative 2. So C equals B over 2 squared. All right, well, the B value is negative 2. And negative 2 over negative 2 is negative 1. Negative 1 squared is 1. So your C value is just 1. So now we've got x squared minus 2x plus 1. That factors to x minus 1 times x minus 1. If you don't believe me, you could do it. Okay? And then you could write that as a squared binomial, just like that. Okay? All right, beautiful things are happening here. This is excellent. The last one. The last one's fun. C is going to be B, which is negative 9 over 2 squared. And you're like, Bacham, that doesn't divide evenly. It's totally cool, guys. It's totally cool. Just like, keep it as a fraction. So if you look at this, negative 9 squared is 81, and 2 squared is 4, right? If you square at the top, you got to square at the bottom. That is also, if you were to write it as a decimal, 20.25. Okay. You could have also done negative 9 divided by 2, which is negative 4.5, and then squared that, which is 20.25. Okay. So what you end up with then is x squared minus 9x plus 20.25, and you're like, Bacham, how do we factor that? Well, just follow the pattern. If you notice, this number right here and this number right here, those are the numbers that you see down there in the factored form. Okay, so that means that that is going to be what we use. So that's x minus 9 over 2 times x minus 9 over 2, or 4.25. Okay, or sorry, 4.5. So then I'm just going to say that's like x minus 4.5, or 9 over 2 squared. Okay, so the pattern that you need to see is that this number here, the b over 2, that's what number shows up in your factored form. Okay, that's a really good pattern to start to notice, because honestly, if you don't notice that pattern, you're going to have a tough time figuring out how to do this. Okay. All right. Beautiful things. Moving on. So now we're going to solve by completing the square. So we've talked about solving by graphing, solving by square roots. We talked about solving with factoring, and now we're going to solve with completing the square. It's just another method. And so if you notice right here, the reason why we're going to complete the square to solve is because it can't be solved with square roots yet, okay? It can't be solved by factoring because it doesn't factor, and it can't be solved by graphing because if you were to go to the graph, you would get a decimal answer, and it's not a pretty decimal either. So when that happens, that's when we probably have a radical somewhere. We have a root that doesn't have a perfect square root or a perfect cube root, okay? We've got a root somewhere, and we have to have exact answers. So that's now where we come to completing the square. But you're like, but Bacham, there's already a C value. And I'm like, yes, there is, but it's not the right one. So we're going to create a new C value, okay? And C is going to be negative B, or sorry, it's just B over 2 squared, okay? Negative 10 divided by 2 is negative 5, okay? And negative 5 squared is just 25. And you're like, all right, that's fine and dandy. Where does it go? Because there's already a C value. Well, just put it on in there, right? So you've got x squared minus 10x. We have this new plus 25, okay? And I'm going to kind of protect that because that's what we're going to end up doing some stuff with, okay? So I protect that with parentheses because that's what's going to factor down. But you still have a plus 7 out here. We can't get rid of that because we started with it. And you should have learned at some point in your math career that what you do to one side of the equation, you must do to the other. So if we added 25 to this side of the equation, then that means that we have to add 25 to the other as well. And that's totally fine. You can do whatever you want to equations as long as both sides have that same thing done to them. Okay, so we added 25 on the left, we must add 25 on the right. Okay, and you're like, all right, Bauckham, fine. What now? Well, this here factors to x minus 5 times x minus 5, okay? You still got the plus 7 equals 25, in which case you're still like, this doesn't help me. Where is this going? Well, the next step that we took in completing the square was writing it as a squared binomial. And maybe now you recognize what is going to happen. The goal is to get x by itself. So we're going to now start getting things away from x. So we're going to subtract 7, subtract 7. So we're left with x minus 5 squared is equal to 18. Okay. Now I'm hoping that you see that you can use the square root method. So we square root, x minus 5 equals plus or minus, okay, 18 breaks down into 9 and 2, 9 breaks down into 3 and 3, there's a pair, so the pair comes out, you're left down here with this, okay, but now we have to then go through and add 5 and add 5. Please do not make that 8 square root 2. Okay, you cannot do that. Those are not like terms. X equals plus or minus 3 square root 2, and then the plus 5 goes on the end. Make sure that you watch your handwriting. The 5 is not underneath the radical sign, but what a lot of people do is they'll say 3 square root 2 plus 5, and I'm like, is that 5 underneath? I don't know. So just be careful with your handwriting on something like that. Okay? This is the correct answer. There's 2 zeros right there. A positive 3 root 2 plus 5 and a negative 3 root 2 plus 5. So if you were to graph it, if you were to plug that into the calculator and get a decimal answer, that's the same answer that you would find if you were to graph it and find the zeros. Okay, so you can always check your work, which is nice. Okay, here we are. Solve 3x squared plus 12x plus 15 equals 0 by completing the square. Okay. Now here's the thing though. There's something interesting about this one that I would like to point out. If you notice, all 3 of those terms can be divided by 3, right? So let's do that. And that's totally fine because now we have 2 sides of the equation. If you divide this side by 3 and you divide that side by 3, that's legal, right? Because what you do to one side, you can do to the other. That's totally cool. So then you're left with x squared plus 4x plus 5, and 0 divided by 3 is 0. And it just kind of gets your polynomial to be a little bit smaller. So I highly, highly recommend that you do that. Okay? Fantastic. So, okay, let's complete the square. We know that we have to complete the square because 5 is not 4 over 2 squared. So that you might get a polynomial that is already a perfect squared trinomial, but these are not. That's why we have to do that. So our new C value is going to be 4 over 2 squared, and then that's 2 squared, which is 4. Okay, so we plug that in, x squared plus 4x plus 4. Those are kind of buddies. You still got a 5 over here, but what you do to one side, because we added 4, we must add 4 to the other side. Okay. Then what we need to do is write this as x plus 2 times x plus 2. We still got the plus 5 equals 4. This is written as x plus 2 squared plus 5 equals 4. Start getting things away from x. Subtract 5, subtract 5. So x plus 2 squared equals negative 1. Some of you might see where this is going. Now we need to square root. So we square root, square root. So we've got x plus 2 is equal to plus or minus the square root of negative 1 is I. Oh yeah, they're coming back. Oh boy. Okay. And so now we subtract 2, subtract 2. So x is equal to plus or minus I minus 2. You could have also written it as, this is more common, x is equal to negative 2 plus or minus I. Either one of those. I kind of like the second way better that I just wrote, just because that puts the I on the end and it is standard form. But there's nothing wrong with the first way either. Okay. All right, this next section is just a bunch of practice. I'm going to talk through all of them. Now, if you want to, fast forward and just look at the answers at the end of this slide, that's fine as well. But for those of you that are like, yeah, I need some more help, I am going to talk through all of them. So it's going to make this video a little bit lengthy, but I'm okay with that. Okay, so here what we're looking at, if you take negative 4 divided by 2 and square it, that's negative 2 squared, and that is equal to 4. So our new polynomial is x squared minus 4x plus 4. You still got the minus 8, but you put a 4 on the other side. I'm going to confine this to 2 steps. I'm going to then say that this is x minus 2 squared, and I'm going to add 8 to be 12. I just skipped a bunch of steps, basically. Hopefully you can see what I did. If not, you can write them all out. You square root, 12 breaks down into 4 and 3. 4 breaks down into 2 and 2. Those are buddies. So x minus 2 equals plus or minus. The 2's come out. You're left with root 3. You add 2. So x equals, I'm going to put the 2 out in front. 2 plus or minus 2 square root 3. Okay. All right. B. 8 divided by 2 squared, that's 4 squared, which is 16. So you've got x squared plus 8x plus 16. You still have the minus 5, but then you added 16. This is going to factor to x plus 4 squared. You add 5 to be 21. Square root, square root. So x plus 4 equals plus or minus. 21 does not factor to anything but 7 and 3, so you keep it just as the square root of 21. You subtract 4, so x is equal to negative 4 plus or minus the square root of 21. Boom. Beautiful. Okay. C is another one where you can divide everything by a negative 3. Okay, so let's do that. Divide it by a negative 3, negative 3. Okay, so then that means you have x squared plus 6x plus 2 equals 0. Okay, 6 over 2 squared is 3 squared, which is 9. So we have x squared plus 6x plus 9 plus 2 equals, well, we added 9 to that side, so then we add 9 over there. This then factors to x plus 3 squared plus 2 equals 9. I'm going to come over here now, keep solving. You subtract, so x plus 3 squared equals 7, square root, x plus 3 equals plus or minus the square root of 7, so we subtract 3, x equals negative 3 plus or minus the square root of 7. Awesome. Okay, that's great. D. Now you could add 68 to the other side, but if you've noticed in all these other ones, eventually that other C value is always put on the other side anyway. So why don't we just leave it over there and complete the square with what you got on the other side. First though, let's divide everything by 4. Okay, so if you divide everything by 4, you will end up with x squared plus 8x equals negative 68 divided by 4 is negative 17. Okay, now we can complete the square. 8 over 2 squared is 4 squared, which is 16. So you have x squared plus 8x plus 16 equals negative 17. But then you also have to add 16 because you added 16 to one side. This then factors to x plus 4 squared. Negative 17 plus 16 is a negative 1. So you square root. You're left with x plus 4 equals plus or minus I. Subtract 4 from both sides, so x equals negative 4 plus or minus I. Okay? If I'm talking too fast, just go back and rewind. It's okay. All right, E and F are interesting because they look a little different, but that's okay. There's nothing wrong with that. Okay? The first thing I would do is notice that both sides could be divided by 6. So if you can make things smaller, please do. That's going to help your life out tremendously. Okay? So we divide by 6. We divide by 6. So that means that we're left with x times x plus 2, which is equal to negative 7. Okay, so we've made it smaller. And you're like, Buckham, yeah, that's great. What do we do now? Well, everything that we've been doing is in standard form. And I've told you that if you don't know how to do something, turn it into something that you do know how to do. And we know how to convert to vertex form. We know how to get it to something squared when it's in standard form. So let's put this thing in standard form. And we do that by distributing. So then we're left with x squared plus 2x equals negative 7. Now that looks like something that you can do. So you take 2 divided by 2 and you square it, which is 1. So we've got x squared plus 2x plus 1 equals negative 7 plus 1. That then factors to x plus 1 squared, and that becomes negative 6. Okay? Now we can square root both sides. So we square root. You're left with x plus 1 equals plus or minus. Okay, 6 only breaks down into 2 and 3. So you can't pull any numbers out, but you can take out the negative by making it an I and leave the 6 underneath. Okay, you can never have a negative underneath the square root. You always need to pull it out as an I. Okay? Okay, then we can subtract 1. So x is equal to negative 1 plus or minus I times the square root of 6. Okay. F is done similarly. So if we divide by 2 first, we get x times x minus 2 equals 100. Okay, great start. If you distribute, you get x squared minus 2x equals 100. Okay. Negative 2 over 2 squared, well, that's negative 1 squared, which is 1. So you have x squared minus 2x plus 1 equals 100. Then you're left with x minus 1 squared equals, plus 1. You got to add 1 to both sides. Equals 101. Square root. So x minus 1 equals, oh boy. Well, the really awesome thing about 101 is it's prime, so we can just leave it, but we do need a plus and minus. 101. And then we add 1 to both sides, so our final answer is x is 1 plus or minus the square root of 101. Oh boy, that's a lot of work we just did. But that's a lot of, it's also a lot of examples. So if you're confused, hopefully by working through some of those or hearing me work through them, you're okay. All right, here's why we really care. I mean, solving is why we care, but we also care because now we can write things from standard form into vertex form, okay, which is pretty cool. So what we're going to do is complete the square. So we've got y equals x squared minus 12x plus 18. Okay, and the reason why we're going to complete the square is if you remember from our goal, right here, you've got something that's squared. So why not? Let's go for it. Okay, the c is negative 12, or sorry, the b is negative 12. So your new c value that you're looking for is negative 6 squared, which is positive 36. So we've got x squared minus 12x plus 36. We still have the plus 18 equals y, but what you do to one side, you must do to the other. And you're like, oh no, what is going on? It'll be okay. We'll get there. Okay? So this then comes down to be x minus 6 squared plus 18, which equals y plus 36. Okay? And equations have looked like y equals, right? So that means that we need to get everything away from y. So subtract 36, subtract 36. So you're left with x minus 6 squared minus 18 equals y. That is vertex form. Now, Big Ideas is going to want you to identify the vertex. Well, you learned how to do that last chapter. Your vertex is negative 6, positive 6, negative 18. That's the vertex. Okay? So now if you need to graph and you're like, I don't know how, you can complete the square, put it in vertex form. You're welcome. Okay, let's do another one of those. Okay, 18 does not create a perfect square trinomial there, so that means we have to make one. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So we've got y. We're going to add 16 to the other side here in a second, so we might as well just go ahead and write that. Okay. Then you're left with y plus 16 equals, this becomes x minus 4 squared plus 18. Okay, and then because we need y by itself, we subtract 16. Subtract 16, so y is equal to x minus 4 squared plus 2. If you wanted to identify the vertex would be 4, 2. Okay, so that's pretty cool in my opinion. Now, of course, we cannot end this lesson without a super cool word problem. So, here we go, last one. Stick with me. You're doing great. The height y in feet of a baseball t seconds after it is hit can be modeled by the function y equals negative 16t squared plus 96t plus 3. Find the maximum height of the baseball by completing the square. So we have to complete the square here. How long will it take to hit the ground? Okay. So we start with this. Now, when we had a coefficient in front of our x squared term, normally we just divided everything by that. But here, 3 is not divisible by 16, so we can't really do that without getting some crazy decimals. So we're not going to. But what you could do is notice that 16 goes into 96. So you could just factor out a negative 16 from the first two terms. 96 divided by 16 is 6. So that would create that. And then you would just keep the 3 on the end. You haven't done anything to change the problem. You've just kind of factored out a great GCF of only 2 of them. And that's fine to do it that way, okay? Okay? So now we can take this right here and we can complete the square with what's inside. So if you have y equals negative 16, okay. Well, negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So I've got 16t squared minus 6t plus 9 plus 3. And you're like, Bacham, go over there and put a plus 9, and I'm going to say no. Okay, because you technically have not added just 9. If you were to distribute this back through, you're going to get something way bigger than 9. And so you haven't really just added 9. You've added 16 times 9, okay? And 16 times 9 is 144. So you need to come over here and do plus 144. That's the biggest thing about this problem, okay? Now, you've got 144 plus y equals negative 16. This now factors to t minus 3 squared plus 3. That negative 16 is just the a value. It's a parabola that opens down. That's why there's a negative, which should make sense because when you throw a baseball, even though it's not a perfect parabola, it can be modeled by a parabolic shape, okay? It'll open down. Now we just need to get y by itself. So we subtract 144, subtract 144. You're left with y equals negative 16 t minus 3 squared. 3 minus 144 is a negative 141. Lies and propaganda. Did anybody catch my mistake? Oh man, I can't believe I did this. Negative 16 times 9 is a negative 144. Holy jeez, I was like, why is my answer different? So in order to get rid of that, you'd have to add 144. Sorry about that. We all make mistakes. And that would create a plus 147. Okay, we're good to go. Okay, so from here, we haven't answered the question yet. The question asks how long, or find the maximum height of the baseball. And the maximum is just the vertex. Well, the vertex is found at 3, 147. And hopefully you understand that 3 feet high doesn't really make sense. And besides, the x coordinate, the t coordinate is just your time. So your max height is 147 feet. Okay? The next part asks, how long does it take to hit the ground? Okay. Well, if we're hitting the ground, then our height is 0. Right? Okay, that's good to know. So if we just solved here, we could find that. Okay, so let's do that. Let's subtract 147, subtract 147. So you get negative 147 equals negative 16 times t minus 3 squared. If you divide both sides by a negative 16, you're probably going to get a decimal, and guys, it's okay. That's just round. Let's see. I did 9.1875 equals t minus 3 squared if you square root both sides, okay? If you do this, well, let's see. Let me get a calculator. Search for a calculator. Where's one? Okay. Let's see. The square root of 9.1875 is going to be, let's see, plus or minus 3.13, we'll call it, okay? So we have 2 options here, okay? Well, and that's still equal to t minus 3. We have 2 options. You can either have negative 3.13 equals t minus 3, or you could have positive 3.13 is equal to t minus 3. So when you add 3, okay, this creates 6.13. This creates a negative 0.13, I think, or something like that. Anyway, it's going to be negative, okay? And you can't have negative time. So this is what we call an extraneous, well, not an extraneous, it just doesn't work, okay? You can't have negative time. So here we actually only have one answer, and it's 6.13 seconds. That's how long the ball is going to take to hit the ground. You could have also gone to your calculator, plugged this in, this part right here, in, and then found the 0. Now, if I tell you to do it algebraically, this is how you do it. But your calculator, thank heaven, will do a lot for you. Okay? All right, guys, good job. That was a doozy. But hopefully you kind of understand what's happening, and hopefully I'll be back soon to help you out with things you don't understand. So thanks for watching. Good luck with the homework.